Hello everyone, I am Muthu. Today my presentation is about quicksort algorithm. Before explaining the quicksort algorithm, let's first see what is sorting. Sorting is nothing but arranging the elements in a specific order, either ascending or descending. It helps in searching, organizing and optimizing the data. Some sorting techniques are bubble sort, merge sort and quicksort. Quicksort is one of the most effective algorithm and it works on divide and conquer method. Divide and conquer is nothing but the given problem divided into smaller subproblems, solves the subproblems recursively and then combines the solutions. Next we see working principle of quicksort algorithm. The four important steps in quicksort algorithm. The first step is choose a pivot element from the array. The pivot element is first element as the pivot element or middle element as the pivot element or last element as the pivot element. Anything one choose as the pivot element. Second condition is partition the array. Smaller elements arrange the pivot left side and larger elements arrange the pivots right side. Third condition is recursively apply quicksort on the left and the right partitions. Final step is combines the subarray, we get the sorted array. Let's look at an example for a clear understanding. You see the unsorted array. The quicksort algorithm is used to solve this problem. First we choose the pivot element. I choose the first element 10 as the pivot element and I additionally take two variables L and R. L denotes left pointer left side and R denotes right pointer right side. Next step is partitioning. First we compare the pivot element and the left variable. The condition is pivot element variable greater than left side and smaller than the right side. But in this place, the pivot element has small value 10 and the left variable has 15 greater value. In this scenario, we move the right pointer variable left side and now compare the pivot element and the right pointer variable. The pivot value is 10 and right variable is 16. So condition is true. Next step, pivot value as 10 is greater and the right variable as 9 is smaller. So in this scenario, we swap the left and the right variable. After swapping the values, now left pointer variable moves to the one step right. Now we compare the pivot value and the left variable. Pivot as 10 and left variable as 2. The condition is true is less than. So next step, left pointer moves to the one step right. Now we compare the left and pivot value. The pivot value is 10 and the left variable is 15. So the condition is false. So the right variable moves to the one step left. Now we compare the right variable and the pivot value. The pivot value is 10 is greater and the right variable is 2 is less than. So in this scenario you don't swap the left pointer variable and the right pointer variable. Now we swap the pivot value because the right pointer variable and the left pointer variable meted. So you swap the pivot value. Now partition the array. The left subarray is 2 and 9. The right subarray is 15, 16 and 11. The left subarray is already sorted, so you cannot consider. The right subarray is not sorted. Now right subarray, the pivot value is 15, the left pointer variable is 16 and the right pointer value is 11. Next we compare the pivot value and the left pointer value. Pivot value is 15 is less than and the left pointer value is 16 is greater than. So compare the pivot value and the right pointer variable. Pivot value is 15 is greater and the right pointer variable is level is less than. So we swap the pivot value and the right pointer value, and now level is the pivot value compare with 16 and 15th. And next step, partition the array. 16 is the pivot value compare with 15, it is the greater value, so swap the value. Finally we get the three subarrays. Combine these subarrays, we get the final result as the sorted array using this quicksort algorithm. Next we see complexity of the quicksort algorithm. First one is time complexity. Best and average case scenario is big O of n log n when the pivot divide into array evenly. Next one, worst case scenario, big O of n square when the pivot is the smallest or largest element. The time complexity is based on choosing the pivot value. The and space complexity, best case scenario, big O of n log n balanced partitions. Worst case scenario, big O of n highly unbalanced partitions. Advantages of the quicksort algorithm. It is efficiency for large datasets and used for finding the kth smallest element and array partitioning. Enhances enhance randomized algorithms with the better experience. Advantages of the quicksort algorithm. It is efficiency for large datasets used for finding the kth smallest element and array partitioning. Enhance randomized algorithm with the better performance used for cryptography and partitioning step support parallel execution for better experience. Disadvantages of the quicksort algorithm. Worst case time complexity when the pivot is chosen poorly, not suitable for small datasets due to be overhead. These are the disadvantages of the quicksort algorithm. Thank you.